Hey guys, Mr. Backenberg here. In this video, we're going to look at applications of linear functions. Taking a look at this first example, we're going to do a little temperature conversion. The relationship between temperatures on the Celsius and Fahrenheit scales is a linear relationship. And what we're going to do is find the linear equation that'll allow us to convert a Celsius temperature into a Fahrenheit temperature. Now, the problem itself doesn't give us a whole lot of information, so we need a couple of points of reference. So a couple of commonly known temperature conversions are the freezing point of water and the boiling point of water. In Celsius, water freezes at 0 degrees Celsius, and in Fahrenheit, that would be 32 degrees. As far as the boiling point of water, in Celsius, water boils at 100 degrees Celsius, and in Fahrenheit, that's 212 degrees. So we're going to use those two bits of information to help us come up with a linear equation to convert Celsius temperatures into Fahrenheit temperatures. Now what I'm going to do with these two pieces of information is convert them into ordered pairs. So this first one, 0 degrees Celsius being 32 degrees Fahrenheit, I'm going to write that as the ordered pair 0, 32. And the 100 degrees Celsius being 212 degrees Fahrenheit, I'm going to make that ordered pair as well. Now, having these 2 points is really all we need to come up with this linear equation. The first thing I want to do is find the slope of this line. So for finding the slope, we're going to take delta y over delta x. So I'm going to take 212 minus 32 over 100 minus 0. Doing that subtraction on top, 212 minus 32 is 180, and on bottom 100 minus 0, well, that's just 100. Now this fraction reduces down to 9/5. So that's the first piece of information that we need is our slope. Now we also need one of the points, and then we can use point slope form to write out this equation. Given these 2 points to choose from, I'm going to use the one that has 0 in it because 0 is typically a very easy number to work with. Now, if we remember, point slope form is y minus y1 equals m times x minus x1. But instead of using x and y, I'm going to use variables that make a little bit more sense in this example. We're talking about temperatures. We're talking about Celsius and Fahrenheit. And if we look at those ordered pairs, we put our Celsius temperature first, so that's kind of like our x value, and we put our Fahrenheit temperature second, so that's like our y variable. So instead of using y in here, I'm going to use f, and instead of using x, I'm going to use c. So using this first point, the 0, 32, I'm going to do f minus the f value of 32 equals our slope of 9/5 times c minus that c value of 0. Now, if we look at the right-hand side, c minus 0, that's going to simplify down to just c. So we have f minus 32 equals 9/5 c. I do want to solve to get f alone, so I'm going to take that minus 32, and I'm going to add 32 over to the right-hand side. And that's going to give us the equation f equals 9/5 c plus 32. So if we have a specific Celsius temperature, we can plug that in for our c value, multiply it by 9/5, and then add 32 to it, and that'll tell us what the Fahrenheit temperature is. As we look at this second example, we want to find the linear equation to convert Fahrenheit to Celsius. On the previous one, we went Celsius to Fahrenheit, so now we're trying to go the opposite direction. The equation that we came up with for converting Celsius to Fahrenheit was this f equals 9/5 c plus 32. If we want to go the opposite direction from Fahrenheit to Celsius, we're going to have to take this equation and solve it to get c alone. So I'm trying to isolate the c variable. So the first thing I want to get rid of is that plus 32. I'm going to subtract 32 from each side. So we get f minus 32 equals 9/5 c. To get rid of that 9/5, I'm going to multiply by the reciprocal. So I'm going to multiply by 5/9 on the opposite side. And then I'm going to flip this equation around because I want to have that c variable coming first. So c equals 5/9 times f minus 32. Now I could take that 5/9 and distribute it in, but taking 5/9 times 32 doesn't necessarily work out very easily. It doesn't reduce down nicely. So I'm just going to leave it in this form right here. So if we have a specific Fahrenheit temperature, we're going to subtract 32 from it and then multiply that by 5/9 in order to get its Celsius equivalent. In this example, we're going to do some actual temperature conversions. So we're going to convert 20 degrees Celsius into a Fahrenheit equivalent. So we just came up with two equations, F equals 9/5 C plus 32, and C equals 5/9 F minus 32. If we're going from Celsius to Fahrenheit, we want to use this top equation where we're plugging in a specific Celsius temperature. So we're finding a Fahrenheit equivalent, so we're taking 9/5 times the specific Celsius temperature of 20 degrees, and we're supposed to add 32 to that. If I take 5/9 times 20, I'm going to end up getting 36. So then I have to add 32 to that, giving me a Fahrenheit temperature of 68 degrees. In this example, we're going the opposite direction. Now we're given a Fahrenheit temperature, and we want to convert that into Celsius. So we want to take 95 degrees Fahrenheit, convert that into Celsius. So we're going to use our second equation here where we're plugging in a Fahrenheit temperature and getting a Celsius answer. So we're going to do C equals 5/9 times our 95 degrees minus 32. Well, if we take 95 and subtract 32 from that, we're going to get 63, and then taking 5/9 times 63, that's going to be a Celsius equivalent of 35 degrees. Last example I want to take a look at, there is actually a temperature that's the same in both Fahrenheit and in Celsius, and we're going to use one of our equations to help us figure out what that temperature is. So we're looking for a place where the Celsius and the Fahrenheit temperature are exactly the same. I'm just going to use my top equation here, and because I want Celsius and Fahrenheit to be equal to each other, I'm going to take the F that's here on the left-hand side, and I'm going to replace it with C since we're trying to make these equal. So then my equation is going to say C equals 9/5 C plus 32, and I just want to solve to get C alone. So the first thing I'm going to do is subtract 9/5 C over to the left-hand side. If I do that, I'm going to get negative 4/5 C equals 32. Now, in order to get C alone, I'm going to multiply by the reciprocal. So I'm going to multiply by negative 5/4 on the right-hand side. So that's going to give me a Celsius value of negative 40 degrees. And because we were looking for a place where the Celsius and Fahrenheit temperatures are the same, what that means is that negative 40 degrees Celsius is the exact same as negative 40 degrees Fahrenheit. That's going to be it for this video. Thanks for watching.